All right, today we're going to tackle something that sounds, well, impossible. We're diving into a mathematical challenge that's been around for centuries, a problem that a lot of people just assumed couldn't be solved. But we're going to look at a pretty fascinating paper that suggests there's a new key to unlock it. But first, let's just start with that big question. Can a math problem actually be impossible to solve? It's a weird idea, isn't it? I mean, we're always taught that if you just have the right method, every single problem has an answer waiting for you. You know, we all started with problems like this one. It's just a simple balancing act, right? You can pretty much just look at it and see that x has to be 5. It feels intuitive, it follows a nice, clear rule. Then, of course, things got a little trickier. You probably remember the quadratic formula from school. Yeah, it's a bit more work, for sure, but it was like this perfect Swiss Army knife for a whole category of problems. It was a tool you could always rely on to get you to the solution. And then, you get this. Yeah. This is a ninth-degree polynomial. Your brain doesn't see a clear path here, does it? It just sees a giant wall. And for a very long time, that's pretty much what it was. So let's really get into our main challenge here. To understand this new proposed solution, we first have to appreciate why this kind of problem, the polynomial problem, has been such a massive roadblock for so long. See, here's the thing. It's actually been proven that once you get to the 5th degree and higher, there is no single general formula, like the quadratic one, that can solve every single version of it. And that's exactly what makes our 9th degree monster so scary. So where do you even start with something like that? Well, you look for clues. And in math, those clues are the coefficients. Those are the numbers out in front of the variables. You can almost think of them like the DNA of the equation. They hold a secret code, and the whole game is about figuring out how to read that code. And that brings us to the star of today's explainer, a paper by Mourad Sultan Ezouidi. He's proposing a totally new way to read that secret code that's hidden inside all those numbers. So in his paper, Ezouidi lays out his game plan. Basically, what this quote is getting at is that the goal is to figure out one set of numbers by relating them to another set. Think of it like this. He's proposing a way to translate the entire equation into a new language, one that's a whole lot easier for us to understand. Now, this is the formula he actually proposes for that translation. And I get it, it looks incredibly intimidating. But here's the good news. We don't need to actually calculate this thing. The really important part is to just understand what it does. Think of it like a decoder machine. You feed the complicated, messy numbers from our original equation into one side, and it spits out a new, much cleaner set of numbers on the other side. So, let's get to the heart of this whole method. It isn't about doing more complicated math, it's about a really clever trick, a transformation that totally changes the problem itself. The whole process really just boils down to 3 steps. First, you take all those original numbers, the coefficients, from that huge equation. Second, you run them through that special decoder formula we just saw. And third, the formula gives you a brand new set of coefficients. Pretty simple in theory, right? Okay, this is where things get really, really cool. Because what happens when you build a new equation using these new numbers is, well, it's kind of amazing. We're about to go from total chaos to absolute clarity. And here it is. This is the result of that transformation. On the left, you've got that original chaotic mess we started with. And on the right, that's the new equation built from the transformed numbers. I mean, the difference is just stunning. It's like all of that crazy complexity just evaporated. So why is this new version so much easier? Well, 2 reasons. First, look at it. Most of the terms are just gone. The transformation turned their coefficients into 0, which basically just erases all that complexity. And second, you can do this really clever little substitution. If you just decide to replace every x cubed with a big X, the whole thing gets even simpler. And once you make that substitution, the puzzle is basically solved. That terrifying, impossible 9th degree polynomial has been transformed into this simple little thing, a cubic equation, x cubed minus 6x squared plus 11x minus 6 equals 0. And this is something mathematicians have known how to solve for centuries. That giant wall has become a doorway. So what are the solutions for this new, simple equation? They're just 1, 2, and 3. Isn't that incredible? The hidden structure of that massive, chaotic polynomial was secretly built on these 3 simple numbers all along. The transformation just allowed us to finally see them. So, The real point here is so much bigger than just this one math problem. It's about the strategy underneath it all, a strategy we can think of as the power of perspective. The big takeaway from this whole approach is that the solution wasn't found by inventing an even more complicated formula to just attack the problem head on. No, it was found by completely transforming the problem itself. It's all about changing your perspective, looking at the problem from a different angle until the complex mess reveals the simple pattern it was hiding all along. And that leaves us with a really fascinating thought to end on. This principle doesn't just apply to math. So you have to wonder, what other problems in science, in technology, maybe even in our own lives, seem impossibly complex right now, but are really just one clever transformation away from a beautifully simple solution? It really makes you think, doesn't it?